Activity 5.2, reflecting points on the coordinate plane. We just looked at reflecting, or not reflecting, but translating points in a coordinate plane. And so now we're going to look at reflections on a coordinate plane. So what you're supposed to do in this activity is take the points from this image and reflect them over the x-axis. That means that the x-axis is the line of reflection. So you're going to take each of these points and move them in a perpendicular distance. So the distance from the x-axis, that's a perpendicular line, so that forms a right angle, and move them to the same distance on the other side of the line of reflection, on the other side of the x-axis. So point B is going to move 5 units, 1, 2, 3, 4, 5 units on the other side of the x-axis, 1, 2, 3, 4, 5. So it's going to move down to this point. And what you're going to notice as you look at these coordinates of these points that are reflected is that the y value is going to change. It's going to become negative. So you're going from a positive 5, in this case for B, to a negative 5. But the x value is going to remain the same. So you're going along the x-axis to the same point on the x-axis. It's like traveling down a road. And instead of turning right or north or in a positive direction, you're going to turn left or south or in a negative direction and go an equal distance in the opposite direction. So E is going to go from 0 to negative 3. So the x-axis is going to remain, the x value is going to remain the same. So you're not actually traveling anywhere on the x-axis. You're right at 0. But you're going to go positive 3. You're going to go in the positive direction 3 units rather than in the negative direction 3 units. You're going to go this way. So E is going to end up here. A is going to reflect down here, an equal distance on the other side of the x-axis. So we can call that a perpendicular distance. It forms a right angle with the line of reflection, or the x-axis in this case. D is right on the x-axis. So the reflection of D is actually just D. It doesn't go anywhere. It doesn't change its y value at all because it's 0. And C is going to reflect up to, it's going to go along the x-axis to 7 units. And instead of going south or in a negative direction, it's going to go positive in a positive direction 2 units. It's going to be 7, positive 2. So here's that image reflected, and notice that, so the pink is the original image, the blue is the reflected image. And remember, we call those corresponding points, we label them with this symbol called prime. So this is B prime, that little mark up there, A prime, B prime, C prime, D prime, and E prime. And so each of those, if you look at them carefully, they are reflected 90 degrees, a right angle, to the opposite side of the x-axis. So some of them end up down here in the bottom half of the grid, so negative y values, and some of them end up here, E and C, in the top half of the grid, or the positive y values. But every case, the x value is the same. You're going along the x-axis the same distance for each point. So here are those perpendicular lines drawn, and they're connecting each of the corresponding points. Remember that word corresponding. So you're looking for where the corresponding point lands on the other side of the x-axis. Where does the corresponding point for A land on the other side of the axis? It's down here. Remember that the y value changes to the negative. So a way to say this is that the coordinates for the reflected point, they remain in the same order, but the y value becomes the opposite value. So it's negative 4. It's the same order. X value is the same. Y value is negative. Negative 4, negative 5. 7, positive 2, because this value for C, the coordinates for C is reflected up here to C prime. So again, here's the perpendicular distance, 2 units from the x-axis, 2 units above the x-axis. And again, that line is perpendicular, it forms a right angle. So I think the cool thing about reflections is that once you're done, take all the lines away, all the coordinates away, and color it in and see what design you get. Oftentimes it's an optical illusion of some sort. It's just a nice design. And so here is this image colored in. And so what I did is I took all the pink and I colored that in solid, and then just colored these parts blue, this part down here and this part up here, and the remaining parts I colored black. And I just think it's a nice image, a nice figure. Kind of looks like a spaceship to me. Okay, another part of activity 5.2 is reflecting the point R over the y-axis. So now the y-axis is the line of reflection. So if that's the line of reflection, that means the values of y are going to remain the same. You're going to travel up the y-axis the same amount, in this case 2 units, but now instead of going right in a positive direction to R, you're going to go left in a negative direction to R prime. So you're going to go in this direction. So notice that the x value now changes signs, but the y value remains the same. So you're going to go up the y-axis 2 units and go in the negative direction 3 units. So this is going to become negative 3, 2. So the point over here is negative 3 and then 2 units up on the y-axis. So the y-axis is the line of reflection. The y value remains the same. The x value is the opposite. It becomes a negative 3 rather than a positive 3. And I like to think of this as, in essence, jumping over a fence to the other side. So you're running up, you hop up, and you jump over, and you always land an equal distance away from the fence on the other side. And this becomes useful in some later activities to think about what happens when points are reflected in later activities. So you end up an equal distance on the other side. So you end up at, so the y value is positive 2, the x value is negative 3. So these are reflections in a coordinate plane.